I'm Angelo Caltan, and today I will be discussing three problems from Chapter 10. Problem 10.4. Three forces are applied to a wheel of radius 0.35 meters. One force is perpendicular to the rim, one is tangent to it, and the other makes a 40-degree angle with the radius. What is the net torque on the wheel due to these three forces? So, the net torque is equal to the torque of the three forces. The torque of the first force is 11.9 newtons times 0.3 meters, which is its distance from the axis of rotation, times sine 0, since it is directly headed towards the axis of rotation. The second torque is 14.6 newtons negative since it is going clockwise direction times 0.3 meters times sine 40. The third torque is 8.5 newtons times 0.35 meters times sine 90 since it is perpendicular to the axis of rotation. Calculating for the net torque, we get the net torque 0.3096 Newton meters going to the clockwise direction or negative. Problem 10.18. We can roughly model a gymnastic tumbler as a uniform solid cylinder of mass 67 kg and diameter 1.2 meters. If this tumbler rolls forward at 0.60 revs per second, A. How much total kinetic energy does he have? And B. What percent of his total kinetic energy is rotational? So for part A, the moment of inertia of a uniform solid cylinder is 1/2 mass times radius squared. So its radius is half of the diameter, which is 1.2 meters divided by 2. Its mass is 67 kilograms. Given these, we can calculate for the moment of inertia, which is 12.06. Next, we convert the angular speed or velocity to rads. So 0.60 revs per second is equal to 3.7699 rads per second. And then to get the linear velocity, we multiply the angular velocity by the radius. This will give us 2.2619 meters per second. Now we have gotten all the values to calculate for the tangential kinetic energy and rotational kinetic energy. Adding both of these will give us our total kinetic energy. So our tangential kinetic energy is 171.39 joules. And our rotational kinetic energy is 85.69 joules. So the answer for letter A is 257 or 257.09 joules. Letter B. What percent of his total kinetic energy is rotational? So to get the rotational kinetic energy percentage is simple. It's just the rotational kinetic energy over the total kinetic energy. This will give us the result of 33.33% of his total kinetic energy is rotational kinetic energy. Problem 10.43. The outstretched hands and arms of a figure skater preparing for a spin can be considered a slender rod pivoting about an axis to its center. When the skater's hands and arms are brought in and wrapped around his body to execute a spin, the hands and arms can be considered a thin-walled, hollow cylinder. His arms and hands have a combined mass of 7 kilograms. When outstretched, they span 1.7 meters. When wrapped, they form a cylinder of radius 24 centimeter. The moment of inertia about the rotation axis of the remainder of his body is constant and equal to 0.40 kilogram meters. His original angular speed is 30 revs per second. 0.30 revs per second. What is his final angular speed? So first, we find his moment of inertia when his hands and arms are outstretched. The formula for this is 112 mass times length squared. So his mass is the mass of his arms and hands is 7 kilograms, and the length of these is 1.7 meters squared. This will yield us 2.0858. Next, we find the moment of inertia when his arms and hands are brought in and wrapped around his body. The formula for this is mass times radius squared. So his mass is 7 kilograms. I mean the mass of his arms and hands. And then the radius is 0.24 meters squared equals 0.8032. And then his initial angular speed is given, which is 0.30 revs per second or 1.8849 rads per second. Plugging it to the relation that moment of inertia times angular velocity initial equals moment of inertia times angular velocity final. We will get that this final angular velocity is 4.8950 rads per second or 0.779 revs per second, which is an improvement over his original angular speed. Thank you.